Hello, everyone, and welcome to the Graphql Meetup. My name is Eve Porcello. I have my contact information up here on the screen. It's at Eve Porcello. Hopefully, we are out there on YouTube right now. Let me know if anyone has joined. Feel free to share comments in the chat, and I can answer all sorts of questions as we go along. So, welcome everyone again. As I mentioned, my name is Eve. This meetup is a collaboration with this.labs, and we're very happy to share this content with you every single month. So every Tuesday, the first Tuesday of the month, we have our own talks that we do, but we also share other talks as well. So we're here in Tahoe City, California. Alex and I work for Moon Highway. We teach JavaScript courses to folks all over the world. We also teach on LinkedIn Learning and Egghead.io, and we have written a couple books. So we wrote this GraphQL book, and we have this new one called Learning React, which is a second edition of our first book. For today's meetup, we're going to be talking about building a GraphQL API with Apollo Server. So if you've never used Apollo Server before, this is a great place to get started. There are many different tools that you can reach for if you're looking to build your own API. One of my favorites is Apollo Server. So this is going to be kind of a workshop style class. We are going to get started with a repo, and we're just going to build a thing. So let's go ahead and get started. So I'm going to copy and paste this link into the chat if you'd like to see that there. We also are going to go ahead and go over to that repo. Once we do, we can download this. So you can clone or download this to your desktop. Okay, so once you have that done, I already have this running over in my project. So give me 1 second. We're going to, let's open this up using VS Code. And we're going to go over what we're going to do today. So whenever we're talking about GraphQL, we're talking about data. So GraphQL gives us this nice repeatable way of taking some data and making it available in our front-end applications or wherever we need it. The way that we get started working on a GraphQL project is we take a look at the data and we start to think about how can we make this available to folks on the internet? How do we serve it up? So here in our project, we have a couple of different data files. These are going to serve like our database. So our lifts.json file, our trails.json file, these are our data types. In the lifts file, we have these objects. So these are objects of data about chairlifts. Chairlifts are just these little things that take you to the top of the mountain, basically. We then have a database, a JSON file called trails.json, and we're going to use this one as another one of our data types. Now, if you want to see this all working and all put together, you can go over to snowtooth.moonhighway.com. What snowtooth.moonhighway.com is, it's a fake ski resort that has a real GraphQL API. So here in the center of the screen, this is the route for our API. So snowtooth.moonhighway.com, we're going to send all of our requests right there to that endpoint. So what we're hoping to do today is we're basically hoping to build this essentially. So I want to be able to send queries to get this data. So I could say all lifts, ID and name. This would give us back a list of objects with ID and name. So we're going to be able to send these GraphQL queries to our GraphQL server, and it's going to give us back some data. All right, so let's get to it. We're going to build this thing. The first step that we need to take in order to make this project work is we're going to install a couple of dependencies. So the first thing I want to install, and let's make that a lot bigger. The first thing I want to install is Apollo Server. When that is installing, actually, it did it faster than I thought. So we'll say npm install nodemon and GraphQL. All right, so that's pretty much everything we're going to need to get started there. We have GraphQL, we have Apollo Server, which is going to be our server library that we're going to use to build this thing. And then we have nodemon, so that as I make changes, the changes are going to rebuild so I can see them in the browser so that I don't freak out about my app not working. All right, so over in our package.json file, we should see these dependencies have been installed. Notice also that we have a start command here. So whenever I call npm start, this is going to run nodemon. And this is kind of a cool thing. It's going to run it on any files that end in either the JavaScript, JS, or the GraphQL extension. So if you want to run nodemon, it'll run on JavaScript and JSON files. But if you want to run it on any other type of files, you can add it here with this -e, this extensions flag. The place that we're going to build our server is over here in the index.js file. So at this point, we see not a whole lot of stuff happening. What we're going to do is we're going to run npm start. And this is going to tell us that we need to build our GraphQL server. So I think that's reasonable. We can we can do that. So let me close that. A couple things that we need to get started building our server are number one, we need to import Apollo Server. And we're just going to require this. So we're going to pull this from the Apollo Server package. And then our server is going to need two things to run. It's going to need a schema. So it's going to need a description of all of the types that are part of this API. It's also going to need resolver functions. So our type defs, this is just going to be a string. I'll use two backticks for this. And inside of this string, we're going to create a type called query. Now, the query type is important. It's important because the query type wraps around all of the different queries that are available on this API. So I can call the first one hello, and this should return a string. Another thing I want to incorporate here is I'm going to pull in this other function called GQL from Apollo Server. Now, GQL is going to go right before rather this template string. So these backticks are wrapping around a string. GQL is going to go right in front of it, and it's going to do a couple different things. One, it's going to allow our server to parse this schema string more successfully. It also is going to allow us to get this nice code highlighting in VS Code. So that's kind of a nice thing as well. Okay, next step, we're going to create some resolver functions. So what on earth are resolver functions? Well, these are functions that are going to get data from wherever it is. So think about where your data lives. Maybe it's in databases. Maybe it's in REST APIs. In our case, it's in these files. So actually, let me move this to the top of the file. So our data is in these two different files. So what I'm going to need to do is I'm going to need to go get the data from those sources eventually. But the really important thing to know about resolvers are these are just functions that are going to return data so that the schema is satisfied, so that the schema is happy. In other words, we're going to create these functions to match our schema exactly. So check it out. We have our query. Inside of the query object, we will have a function called hello. What does hello return? Well, it must return a string. So we can say hello GraphQL Meetup. Awesome. Once we have our type defs and our resolvers created, what we can do is we can get rid of this console message, and instead we want to create our server. So we're going to say const server equals new Apollo server. And inside of this server constructor, we'll pass in two things. We want to pass in the type definitions, so the schema, and we want to pass in the resolvers. So type defs, resolvers. Once our server is created, we can then add server.listen. This is going to start our server, and then we can do this. We can say console log server running on port URL. So we'll destructure that from that object as well. All right. So we did a couple different things here, right? We have the imports. We've imported these things. We have our type definitions, which is our schema. We have our resolvers, which are the functions that go get the data wherever it is. And then we have our server. So the server is going to be created with these two things that we need. And finally, we'll start it up. So if nodemon is working as expected, Npm Start. Oh man. Problem with node modules UUID. What a bummer. All right, let's try fixing that. So always my first go-to is to uninstall it or to delete my node modules folder and try reinstalling it. Then we'll run npm install. That's not running, so that's good. Let's go back. Okay, so it looks like there's some sort of problem with UUID. That is not cool. But here's how we can fix that. So I'm going to change the version of Apollo server, and I'm going to lock it. And I'm going to try to do a little workaround here to make sure that that's not a problem. I'm also going to get rid of the package lock, which I should have done in the last cycle of trying to unplug it and re-plug it in again. Then I'll just get rid of those two. Cool. Next step is I will try reinstalling, because I think that the problem is with this dependency of Apollo server. That's what I get for updating the versions of this today. Shouldn't have done it. This is my installation dance. Let's see if that works. Oh man, I'm getting so burned today. Let's see. The good news is this isn't live. We don't see people watching this, so. This UUID is causing me problems. So I deleted that UUID folder. Cannot find. We all expected that, right? Let's roll this back even further then. 2.9. What will that do? I wonder. So let's clear that out. We will never tempt the live coding gods. You're right, James. But that's okay. I'm going to stay calm in this very hot room in my house If it looks like I'm sweating because of this, I promise I'm not. All right, let's see how that does. I'm also going to use this version 14 of GraphQL Server because I think these are a little closer to being on par. So let's see how we do with that. Let's try npm installing this stuff again. Boom, there we go. So there we go. We're running. So let me just recap what I did. I got backed into a live coding corner. So what I did to solve the problem was I just changed the version of Apollo server. I think probably something related to there was a dependency for UUID, which just generates a unique identifier. So that's not even something we're going to use today, but because npm we have so much dependencies going on, we backed ourselves into a corner. So what I did was I changed the version to 2.9.0. I changed the GraphQL version to 14.0.0, and now it's working. So we're not going to get stressed out. This is just fun. So we can check to see that this is working. Usually that part is a lot faster than that, but that's okay. It is what it is today. So what's going on now is that our server should be running on localhost 4000. Remember, localhost 4000 is our local version of what we're hoping to build, the snowtooth.moonhighway.com site. So I can just copy and paste that over into the comments there if you want to check that out. You can send the same types of queries to that one as well. Now, if I go back to our playground, the real one this time, I need to close this or I'm going to go insane. So here in the middle, we see that this is our endpoint, localhost 4000. And we're going to send a query just for the hello string that we want. So we can go ahead and say hello. And this is working. Hello, GraphQL Meetup. So usually that happens a lot faster if we're not dealing with npm, but we're going to let that go. And we're going to, we're not going to take it personally. We're not going to get too upset. All right, so we did our hello world with GraphQL, but really what I'm here to do is to model our data. So I'm trying to create an API for our lifts and trails. So I need to start to think about our data, and I want to start modeling it with GraphQL. So let's go ahead and do that with the schema. So remember, the schema is this document that describes all of our API's types. So if there's a lift, we need to create a lift type. So type lift is going to have an ID. It's going to have a name, which is a string. It's going to have a status, which is a lift status. Let's also add a few other fields here, capacity and night. So what's cool about GraphQL is that even if your data, even if you have tons of different fields that you want to use, or perhaps there are some you want to skip over, you can literally look at your data wherever it is, and you can say, let's pick this one, let's not use this one, and only model the fields that you want to. The next thing that I'll do is I want to create a query in our schema to make this work. So a couple different queries I could make. Number one will be lift count. So lift count should return an int. There are 5 scalar types that are part of GraphQL. One of them is an ID. We also have a string. We have an int. We have a Boolean. And we have a float. So anytime we want a field to return a single value, we can use a built-in GraphQL scalar for this. So this is what that's all about. Every time I send a query called lift count, I want it to return a number. Now, the next thing that I'll do is remember our resolvers are in charge of going to get the data to match whatever is in the schema. So I can replace this hello query, because we don't have it anymore, with a query called lift count. Now, how do we decide how many lifts there are? Well, our database is pretty easy, right? It's just a quick little JSON file. So I'm just going to say lifts.length. So literally, I just want the length of the array. And then every time I send that query, we should be able to find it. Now, something else I notice here, and this is a good thing, we saw an error before, and that was stressful, but we're much less stressed out now because this error is actually helping us figure out exactly what's going on. Whenever there's a mismatch between what's in the schema and what's in the resolvers, we need to ensure that we fix this problem. So we're basically the query here is asking for lift status. The schema is asking for lift status, but it doesn't exist. So what we need to do is we need to create an enumeration type. So we'll create this enum called lift status. And then inside of this lift status, we're going to have open, close, and hold. Awesome. So let's see what this looks like. NodeMon has run again. We got server running on localhost 4000. And now what we can do is we can send our query for, and sometimes you need to hit refresh on your browser just to make sure that it's working. We do have NodeMon set up so it will reload, the query will work. But if you want to see this working with predictive text, in other words, you want to be able to type and select an option, we need to hit refresh. So once I do it, we see our lift count is 11. There's 11 lifts that are available at this mountain. That's something to kind of talk about too. When we're using a tool like this, the Graphql Playground, if I hit Control Space, this is going to show me all of the different queries that are available in this API. So right now we only have one of them. But as we add more and more content, as we add more and more fields to this, that is going to really help us out so that we don't have to worry about memorizing this stuff. If you take a look at the documentation panel too, we see our lift count has been added and lift count returns an int. I should have asked, what does this exclamation mark mean in the schema? Anyone have any guesses? Let me move this over here so that we can respect our screen a little more. Okay, cool. There we go. Yeah, so what this means is that this is required. We must return a value, and it's non-nullable. So the value that is returned from lift count can never be null. All right. So far, so good. Let's go ahead and add on to this, though. And what we want to add on to this with is a query called all lifts. All lifts should return a list of lift objects. Nice. So thanks, James. I appreciate it. You're allowed to go back to work. That's totally acceptable. And Mixed Bit Media, hello. Hope everyone's having a good day too. Thank you all so much. So what I want to do is, now that we have created our query, so here on line 22, we have another query for all lifts. Whenever I send this query, it should return a list of lift objects. So the way that we're going to do this here is we'll literally write a query called all lifts. And then we want to return lifts. Let's check it out. So again, we're going to hit refresh on this. And the reason is so that it refreshes the schema. We see all lifts here, returning a list of lift objects. Now, when I send a query for all lifts, we can access all of the fields. name and status, for example, we should see all of those being returned. How cool is that? I think it's pretty cool, at least. All right, let's try a little bit of filtering and selection in GraphQL. So here on line 23, what I want to do is add a query for find lift by ID. Now, find lift by ID should take in an ID, and this is going to be a non-nullable value. We always need to supply that in order to run the filter appropriately. Then on the other side of the colon, we will say lift, because we want to return the entire lift object after we select it. This is the process of building a GraphQL API. We have all these additions to our schema, and then we're going to go ahead and add this to our resolvers. So let's do it. We're going to say find lift by ID. And then here's where things get interesting. What we want to do is we want to, and let's scroll up on that a little bit. I'm going to pass in this value called parent. Now, at this point, I'm not going to explain what parent is. And I know that that's bad. So I'm going to say to do, remind Eve to explain parent in a minute. So that's going to keep me accountable so that I explain exactly what that is. But really, I'm trying to skip over this right now so that I can get to the second argument. The second argument that is passed to this find lift by ID function, or the second argument that's passed to any resolver, is arguments. So what I mean by that is when I send a query called find lift by ID. Now, I haven't written this yet. It's not working. However, it will in just a second. So when I send this query for find lift by ID, I want to be able to pass in the ID, like Astra Express, of a particular lift. Then once I do that, I want to return fields on that lift. And we're not quite there yet. It's not quite working. But here's where we can make it work. So these arguments, the second argument that is passed to every resolver, that's how we're going to be able to capture these values from the user and filter accordingly. So we're going to capture those from the user, and then we're going to take our lifts array, and we're going to use the find method of JavaScript, and find is going to iterate through an array, and it's going to find a single object inside of it. So we'll say find, we'll pass in each lift. So for each lift, we want to compare args.id with lift.id. So in other words, when we're literally looping through data, I want to look at each one of these objects, and anytime I see a match, it's the first one, so it's not that exciting, but anytime I see a match, it's not that one, it's not this one, oh, we got it, it's the first one here. So it's going to find that one, and it's going to pass back to me the entire object. So let's take a look at how this looks. Where, oh, where is our code? There we go. So index.js, this should be everything we need. So let's go back here. And now we're able to find this object. Pretty cool. So there's a question there, how do you create the playground? Well, whenever we create a server using GraphQL, in this case, we're using Apollo server. Apollo server, whenever we create a new one, whenever we call listen on that server, our playground is going to be served up on localhost 4000. Every one of these server libraries ships with some sort of version of this, either the playground or Graphql, usually. You may have seen Graphql if you've used the GitHub GraphQL API. That's a place that Graphql is used quite a bit. But this allows us to interact with the data. So Instead of using something like maybe Postman, where we're pinging REST APIs, we can use an interface that looks like this. And something that's kind of cool is that Postman incorporates GraphQL now. So everyone is getting on board the playground train, the GraphQL train. All right. So let's go back. So far, just to recap what we've done, we have created our schema. We have created some resolvers, lift count, all lifts, find lift by ID. So no one is really yelling at me yet, which is okay, but I want to make good on my promise to explain parent in a minute. So in order to explain parent, I really need to first talk about our trails. So let's go ahead and add a trail type. We have trails.json, right? So we need to create a GraphQL object. We need to create a GraphQL type that looks like this. So let's go ahead and add ID, name. We'll say difficulty. And for the sake of simplicity, I'm just going to add that. Next up, I'm going to add a trail count query. And then I'll create an all trails query. Sweet. I'm also going to split my screen so that if you're following along, you can sort of see a little better. So over on this side of the screen is our schema. Over on this side of the screen are our resolvers. There we go. So again, whenever you create a query, like we did here on line 29, trail count, all trails, etc., if you don't immediately add a resolver for them, you will get in trouble. So that's a joke, but you will need to create them. So let's go ahead and create those resolvers. The first of these is called trail count. And this is going to be literally the same thing as this, but for trails. So we'll return trails.length. And then all trails should return trails. Check it out. We're going to send a query for all trails. We're not going to see it there yet because if you do want to, you can hit refresh. So ID, we got name, and we got difficulty. So ID, name, and difficulty are coming back for each. We'll also look at trail count just for good measure. And it looks like we got 71 trails going on. So far, so good. So we're creating this API for a ski resort, right? We have a lift type, we have a trail type, but really kind of the power of GraphQL is how do we fit everything together? How do we connect the dots? How do we draw links between different types? The way that we do that in GraphQL is with fields. So what I'm going to do first is I'm going to get back to this whole thing where all of you are to yell at me and remind me to explain parent. So, okay, I'll do it. Here on line 14, let's go ahead and add a URL, and a URL should return a string. All right. Now, once I do this and we take a look at our lift, the actual data doesn't have a URL field on it. We see name, capacity, status, night, elevation gain, time, trails, and ID. No mention of a URL. But I've added this here. But because I've added this here, sorry for all the back and forth. Because I've added this here, we need to create some sort of resolver to return some data for this field. The way that I do this in the resolver functions is outside of this query object. So notice I'm putting the comma after this. So right between here, we're going to say lift. And we're going to create a custom function that's going to return something for this URL. The only rule about this is it has to return a string. So we can handle that. So what we'll do is we'll say URL. Every time I call this function, we just want to return a string. So it'll say lifts.html. It's kind of a string there. Let's take a look at it in the browser. What I'm most interested in is that URL field and also name. Okay, so think of all of these fields as mapping to functions. I keep saying the same thing over and over again, but it's important because we want to think about when I send this request, we're going to call a function for every single field in this query. Now, our lifts query, all lifts, is just going to return some data from the it's just going to return some data from the database, in this case, a JSON file. But if we don't have anything there, we can create a custom function like we've done here to return a string that matches. So every time I call this function, it's going to return this string. But really what I want to do here is I want to customize this. So this is where this parent object comes into play. So I'm going to remove this to do because I'm doing this now. I'm going to explain what does parent mean. Parent was that placeholder we used to access the second argument, but what does it do if we're just using that? So what the parent is it's the parent object. So think about this in context with the lifts. So every time I return an object in the all lifts query, we are going to look for, in this parent object, we're going to look for the ID. Let me show you what this looks like. So here on line 45, instead of sending lifts HTML, I'm going to say parent.id. And we're going to just concatenate this into the string so that each one of these lifts has a custom URL, Astra Express, Jazzcat, Jolly Roger, whatever, based on the ID of that particular lift. In addition to this, though, the URL field, or sorry, the parent object rather, is going to help us to connect pieces of data. So let's take a look at how this works. Inside of our lift object, and let's split this to the right so that we can see both again. So inside of this lift object, we're going to add another field here called trail access. And trail access should return a list of trail objects. So back to our data here, right? Our trails, or sorry, our lifts, they don't have a field called trail access. Doesn't exist. But it does have this array of trails that we can use to look up all of these trails based on their ID. So this is just an array of IDs so that I can go look at the trail data and I can see, hey, does this match? Did we find it? Is this off of that lift? And if so, we can return it. So here's how that'll look here. We need to create another one of these custom resolvers. So we'll say trail access, and then we'll access the parent again. Match this, even though Prettier will do that for me in a second. And now what I can do is I can say parent.trails. I want to open this data again. So parent.trails. So look in this object Then look at the trails field. Then map over all of the trails that are in that array. Map. For each one of those IDs, we want you to look in the trails field, or we want you to look in the trails file, trails.json, and we want to find objects where there's a match. So we'll say ID equals t.id. Right. So let's see if that works. What we're trying to do is we're trying to find the list of trails off of a particular lift. So if I ride up the Astra Express lift, I want to know what trails are options for me to ski down. So trail access, this is going to return a list of trails, name. Sweet. So now check it out. We got our trails off of each one of these. Pretty cool. Questions about that? Somebody asked me which VS Code theme I'm using, and I'm happy to talk about that. This is the Night Owl theme, designed by Sarah Drasner. You can get it by going up to, let's see, preferences and color theme. Or sorry, you would look it up in the extensions, but I'm using Night Owl Light. So there's Night Owl Dark and Night Owl Light. I think this is a little easier to read for students, but when I'm working on my own projects, I usually use the dark theme because developers like their dark themes. So that's that. So that's how we make that connection between trails and lifts. We're just going to access that off of the parent object. Okay. There's one last thing I want to show you before we wrap up today, and that's how to create a mutation. So we've looked here at queries. Queries are going to go get some data for us. Mutations are going to change data. So whenever you have verbs in your application, you need to change some data, like creating an account or logging in, or in our case, setting the status of a lift. What we want to do is we want to create a mutation for that, and then we'll follow the same process. We'll create it in the schema. Then we're going to go ahead and create it in the resolvers. So let's do it. Here on line 34, I'm going to create a mutation. And this mutation is going to be called set lift status. Set lift status will take in the ID and the status, the desired status of what we want to create. Lift status. And it should return a lift. Let me close this because we can't see this at all. So this is our mutation, right? We have set lift status. This will take in an ID and a status, and it'll return a lift. Once we've done this, we can then create a mutation in our resolvers. So you don't have to put it at the top. Usually I wouldn't put it at the top, but I will in this case just so that we can see it all on the same screen as our mutation up here in the schema. Our mutation resolver is going to match the name of the mutation in the schema exactly. So we'll say set lift status. Set lift status is, again, just a function. But this function is going to be responsible for taking in the arguments from the user. So we'll say parent args. And what we want to do is we want to find the lift that we want to update. So let's say the panorama lift is open and it gets really windy and we want to be safe. We can close that with this mutation. So we'll say let updated lift equal lifts.find. And then for each one of these lifts, we want to match the args ID with the lift ID. Okay, so we found it. The next step is we want to take the status and update it to whatever the status was that was supplied by the arguments. Finally, we want to return it. So we'll just return the updated lift. Okay. So far, so good. Now we want to give this a test, and I'll put that back on the screen in a second if you're following along. We want to give this a test. Set lift status should take in the ID of the lift we want to change. Do we have any statuses here? We don't, but that's okay. Panorama and status will be open. Then because our mutation returns a lift type, what this means is that we have access to all of the fields that are on that lift. So we can say name and status, and that's fine. That's enough. All right. Cool. Let's give it a shot. Now it looks like we have set our lift status to open. And then you can always toggle this back and forth. Closed. Hold is another one. There we go. So that's what that set lift status mutation looks like. Notice that we're just updating the data in memory, which kind of isn't that exciting, but just know that you can use these functions to go get data from anywhere and to change data anywhere that it lives. So I actually want to show you something. If I can find it in a relatively short period of time. Okay. Nice. We'll find it. How's everyone doing? Staying awake? Staying alive? Okay, I have a point here. So my point is this. Right now, we're dealing with data from these JSON files, trails, lifts. But we want to think about GraphQL as being this server layer on top of many different services. It could be on top of REST APIs. It could be on top of anything. So this is an example of a slightly, and I'll copy this link to everybody. This is an example of a slightly more advanced version of the app we're working on right now. The difference here is that we have our trail data, we have our lift data. But the important thing that we do here is that we're incorporating data from a REST API from a third party. If you've used the Strava API or if you've used the Strava app, it's an app that tracks your activities. So if you go on a bike ride, it'll track how far you rode for and how long it took you. Now, if we wanted to take that data and pull it into our ski day or our ski application, what we can do is we can create a type to model the data that's part of the Strava REST API. So Strava is all about activities. We have IDs, names, distances, types, and times. Then if I scroll down a little further, I have a field here called My Activities. And the My Activities query will just return a list of those activity types. And then finally, here's the cool part. I was just so excited to show you the cool part. We have a resolver here called My Activities. And My Activities is a resolver function that's going to go get the data from this API. Notice here that it's an asynchronous function. So we use the async await syntax to handle this asynchronous request. We're sending a fetch request to the Strava API. We're passing in some headers with it, so we'll be able to pass our Strava token in, and you can place your Strava token there. Once we make that request, we authenticate ourselves, we return the results. So this is just to show the flexibility of working with GraphQL. We're not always just talking about a certain type of database or a certain type of REST API or cloud services that we're wrapping. We can use these functions to go get data from anywhere. And then we can use these functions to really orchestrate a lot of different types of data. So I think that's kind of cool. So we have talked a little bit about working with these APIs. Remember, let me pull this up. Remember this link here, github.com/GraphQL workshop/Snowtooth API. You can always refer back to this if you'd like to, if you want to work on a project. There are a couple more iterations that we go through in this course. So if you want to look at the complete branch, you can. This will show you everything you need to finish this up. All right. Well, cool. Well, that is all the official content that we have for you today at the GraphQL Meetup. I'm very honored that all of you joined us today to learn a little bit more about GraphQL. I would encourage you to look at the Apollo GraphQL documentation. In it, they have a tutorial. So if you look at the docs, there's a ton of different tools and features that you can use, but there is a free tutorial that you can take that will take you through the steps of building your own Apollo server. If you have questions about anything, always feel free to send me an email. You can find me at eve@moonhighway.com. And we will be back next month. Next month, we'll be talking about Apollo Client. We'll have some special visitors from Apollo for that meetup. So put that in your calendar. September 1st is the next one. But I want to thank everyone so much for being here. I hope you enjoy the rest of the day and have fun building these GraphQL servers. See you later.